Yes, sir, let's start.
Yeah. So, hello all, welcome to the IIT Engage classes. In this particular session, we are going to cover the fluid mechanics and fluid machinery subject solution of GATE 2022 set 1, right? So, coming to the marks wide distribution in this particular paper, you can see here section B, fluid mechanics and hydraulic machines. The 1 mark question were 2 and the 2 mark question were 3. So, total 5 questions were asked. And the weightage, you can see there is a weightage of 8 marks, right? For this fluid mechanics and hydraulic machines. Coming to the question number 1, here you can see this question from the fluid mechanics. A tiny temperature probe is fully immersed in a flowing fluid and it is moving with the zero relative velocity, right? So first of all, here a zero relative velocity, here you can see that with respect to fluid, the velocity filled in the fluid is given as the velocity vector u I cap plus v j cap, where u and v component of velocity is being given, which is a function of time. That means it is a unsteady flow. And there is a temperature field also, which is given in this particular fluid. It is also a function of what? Space and time. You can see that t, which is equal to 2x square plus xy plus 4t, where x and y are the spatial coordinates and t is the time. The time rate of change of temperature recorded by the probe at x equal to 1, y equal to 1, and t equal to 1, right? So before proceeding, this is one of the good question related to what? Again, mathematics, right? If you know the total change of variable, right? Whenever you write any function like let's say f, which is a function of x, y, z, then what is the total differential df you write? This is I am explaining the maths part. So df you write dou f by dou x into dx, dou f by dou y into dy, dou f by dou z into dz. Similarly, here, what is the temperature? If you read here the temperature is being given as, I'm writing here temperature for you, which is given as 2x square plus xy plus 40. 2x square plus xy plus 40. So from here we can say confidently that it is a function of xy t, right? And what is the velocity vector which is being given? Velocity vector is given as 2xi plus y plus 3tj. 2xi y plus 3t j cap. That means this is the velocity vector if you write u I cap plus v j cap, where u is given as 2x and v is given as y plus 3t. But we need to find the time rate of change of temperature. But what is the total change in temperature? dt. Just try to correlate this one. Dou t by dou x into dx. Dou t by dou y into dy. Dou t by dou t into dt. But this, guys, this we have to do the differentiations. Again, we need to find time rate of change. That means we need to divide with the what? Time, guys. Right here we can write dt. But we need to find what? dt by dt. So with each and every term we will divide with the what, guys? dt. So this will be 1. So what is the dt by dt, guys? Here dou t by dou x. Now what is the dx by dt? If you see the Lagrangian approach we follow, if you try to take the difference of like if you take a no If you differentiate position with respect to time, you are going to get the velocity vector. But you are saying that dx by dt means what? It is u. What is the dy by dt? It is v. Similarly, here also we will try to substitute u plus dou t by dou y into v plus dou t by dou t. Here, understand the next particular part. What we need to do, we need to find the dt by dt at x equal to 1, y equal to 1, and t equal to 1. So for that, first of all, we need to differentiate dou t by dou x. What is the dou t by dou x from here? Dou t by dou x, if we try to find 4x plus y. And what is the u, guys? U is given as 2x. So 2x, 4x plus y. What is the dou t by dou y? Dou t by dou y from here, guys? Dou t by dou y. So again, we are differentiating. So 2x square, there is no y term, so it will be 0 plus. Again, if we try to differentiate by taking x as a constant, then you are going to get what? X plus 0. So finally, you are going to get x. And what is the v? Y plus 3t. Y plus 3t. And what is the dou t by dou t, guys? If you try to differentiate here with respect to time, you are going to get 4 because 2x square in the first term there is no time variable. In the second term also there is no time variable. In the third term we are having what, guys? 4t. If you differentiate, you are going to get 4, right? So finally, what we get here? Plus 4. But they are saying we need to find the value when x equal to 1, y equal to 1, and t equal to 1. So if you substitute the values at x equal to 1, y equal to 1, and t equal to 1, you are going to get 2, 4 plus 1 plus 1, 1 plus 3 plus 4. So finally, what you are going to get, guys? It is 10 plus 3 plus, yeah, sorry, it's a 4. 10 plus 4 plus 4. That means you are going to get 18. That means what is the total time rate of change of temperature which is being recorded by the probe at a particular location which is being specified in the problem is what, guys? 18. So which option should be correct? C should be correct. C should be correct, guys. So this is regarding question number 1. Only thing is that you need to have some basic understanding of mathematics differential equation. Coming to the question number 2 here. Question number 2 again from the compressible flow. You can see here what they have given. They have given the convergent nozzle, right, which is being fixed, which is being connected to reservoir, right, and then it is being connected to the what, guys? Some chamber, back pressure chamber. The figure shows a purely a convergent nozzle with a steady, inviscid, compressible flow of an ideal gas with a constant thermophysical property operating under choked conditions. The exit plane shown in the figure is located within the nozzle. If the inlet pressure P0 is increased while keeping the back pressure unchanged, which of the following statement is or are correct? The first statement you can see here, what they have given. The mass flow rate through the nozzle will remain unchanged. The Mach number at the exit plane of the nozzle will remain unchanged at unity. The mass flow rate through the nozzle will increase. The Mach number at the exit plane of the nozzle will become more than unity. Right. So before solving this question, we will have some basic understanding of convergent nozzle. Here, if I draw the figure, Here we have the back pressure. Here we have the inlet pressure, reservoir pressure PB, and there is the exit plane. This convergent nozzle, what is the heading? I am heading putting as convergent nozzle. First of all, we have seen that when the inlet pressure P naught is equal to PB, then there is a no flow because there is no driving force being present. The moment if we decrease the back pressure, the moment we decrease the back pressure, what will happen, guys? The mass flow rate will be keep on increasing. And you know one particular graph where we have seen the maximum mass flow rate versus pressure. For example, if I draw here the dimensionless parameter like mass flow rate to the maximum mass flow rate and P divided by P naught. So if you try to see this particular plot, guys, here back pressure versus P naught, then definitely you will observe that we are going to have the graph like this. That means here we have the P star over P naught. That means there is a certain amount of critical pressure. If it is reached beyond that, we cannot increase the mass flow rate. That particular mass flow rate we are corresponding to one condition we call that is nothing but choked conditions. What is the meaning of choking condition? The maximum mass flow rate that can be attained by that particular convergent nozzle when the Mach number become 1 at the throat section. But the thing is that this graph is only valid for this particular statement that when we achieve the condition of a choking, then we can have the maximum mass flow rate. That is the fixed mass flow rate we are going to get. But this is valid under one assumptions. That assumption is what this P naught remain constant. That means this graph is valid only for one P naught. This is the mass flow rate you are going to get. For example, you are going to get the maximum mass flow rate. For example, 1 corresponding to P naught 1. But if I increase the P naught, what will happen, guys? If I increase the P naught, this graph will be little bit shifted like this. This graph will be shifted like this. This is the maximum mass flow rate corresponding to different P naught 2. It is P naught 1, where P naught 2 is more than P naught 1. So maximum mass flow rate will be more than the first mass flow rate corresponding to P naught 1. It is not like mass flow rate will remain constant. That statement is true when P naught is remain constant. When you try to if you try to change only the back pressure, then only this particular graph is valid, the red color graph. But whatever the blue color graph which we have plotted just now, that is by changing the pressure. Now, what is the relationship? That is a big question mark. What is the relationship between this maximum mass flow rate and inlet pressure? Maximum mass flow rate, if you try to see, when the choking condition is being achieved, when the choking condition is being achieved, at that particular point, what is the maximum mass flow rate? A star, which is nothing but sonic area, throat area, you can say. Here we have the P naught under root of K by RT naught. Two K minus 1. You can see this particular formula. By this formula, you can see that the maximum mass flow rate is a function of P naught, T naught, and K. Where if I increase the P naught, definitely mass flow rate will increase, and that is what happening. That is what happening in this particular graph. And what is the relationship between this choke pressure as well as this one? If you see the P naught is what, guys? 1 plus K, 1 plus K divided by 2 to the power what, guys? K by K minus 1 PB. This is the relationship we have, guys. The moment we achieve what, guys? The moment we achieve the choking condition, the Mach number cannot be more than one. Mach number will be equal to one. But what about the mass flow rate? Mass flow rate will be keep on increasing. If you try to see the plot, the mass flow rate versus P naught. That means I am reversing my decision. Initially, I was decreasing the back pressure in thinking of increasing the mass flow rate, but now I am keeping the back pressure remain constant, and I'm plotting the graph between mass flow rate and P naught. Let's see what happens. So here you can see in this scenario, for example, if P naught 1 is equal to PB, again there is a no mass flow rate. Right? The moment you try to increase the P naught, what will happen? The graph will be moving like this, and it will try to increase till what, guys? It will achieve the sonic conditions. That means it will achieve the choking condition. That means when P naught will become what? P naught star. P naught star is what, get PC. How to get the P naught star? By using this particular formula, P naught star. PC, which is equal to P naught star, which is equal to what, guys? For gamma equal to 1.4, or K is equal to gamma, which is equal to 1.4. You are, if you are trying to calculating, then what you can get? 1 plus 1.4, 2.4 divided by 2 to the power 1.4 over zero point 0.4. So you are going to get 1.893 PV. That means when your choking pressure will become equal to some star pressure, that is a P naught star, which is equal to 1.893. Then only we say what, guys? The choking condition has been arrived. After this, my dear friend, what will happen? We need to follow this particular equation. In this equation, P naught and mass flow rate, how they are varying? They are varying linearly. So the graph will increase like this. The graph will increase like this. After attaining these particular choking conditions. This is the choking condition. Right. So what you're understanding from this particular question, they have just twisted this question. Reverse, they are asking. What they are asking? When the P naught will increase, the mass flow rate will be what, guys? Mass flow rate will increase, but the Mach number at the exit plane of the nozzle cannot be more than unity. That is fixed. Because Mach number equal to 1 when we have the smallest area, which is nothing but throat area in this particular case. That means exit plane of the nozzle. Here, what do we have? Exit plane of the nozzle. So these things you need to understand, which is very, very important regarding these questions, right? Just like what we have seen, when the P naught will remain constant, when you try to decrease the back pressure, you cannot achieve the choked mass flow rate. That is the maximum mass flow rate. After that, it will remain constant. You cannot get more than, for example, 6 kilogram per second. But here, you can attain more than the 6 kilogram per second when you try to increase the P naught also. And that is what I have explained the situations. But still, mass flow rate will keep on increasing. That doesn't mean that the velocity will increase and that will increase the Mach number more than one, right? With the help of convergent nozzle, there is a drawback. We cannot achieve more than sonic speed with the help of convergent nozzle. We need to attach what, guys? We need to attach diverging portion. That's why we need the CD nozzle. That's why we have the CD nozzle in all the applications. To achieve the supersonic speed, we need to attach what, guys? Diverging portions. Right. So that is regarding question number 2. Moving on to the question number 3 here. Now try to see this question, guys. Here what they are asking, a solid spherical bead of certain material, that material is lead, which is having a density of 11,000 kilogram per meter cube of diameter d, which is equal to what, guys? 0.1 mm. It is sinks with the constant velocity in a large stagnant pool of a liquid which is having a dynamic viscosity 1.1 into 10 power minus 3 Pascal second, or we have the kilogram per meter second, right? Both the units are for the dynamic viscosity. The coefficient of drag is given as CD which is equal to 24 by RE, where RE is what guys? The Reynolds number which is defined based on the diameter. You understand whenever we take the spherical bead, for example, a spherical bead is there like this. Suppose flow is happening like this, or the flow is happening like this. Always, if you try to project the area, whenever you take a sphere or ball, when you see the side view, how it will look like guys? It will look like a circle. So that's why what is the projected area? The projected area will be pi by 4 d square. And that is what the projected area is being given in the problem. And because when we project it, you are going to take the circle, which is having a certain diameter d, which is nothing but small d. And on that basis only, we need to find the Reynolds number. These things which I am explaining right now, they have mentioned in the theoretical format. You can see that the Reynolds number is defined on the basis of diameter of the bead. Now, further, if you read the statement of this question, what they have mentioned, guys, the drag force acting on the bead is expressed as CD 0.5 rho v square into projected area pi by 4 d square. Don't take don't take the surface area of the basically, or maybe the area of the what sphere, guys. We need to take the projected area, right? Rho is nothing but the density of the liquid. Rho is nothing but what, guys? A density of the liquid. Neglect the buoyancy force using the g, which is equal to 10 meter per second square. What is the velocity? And remember, this velocity is nothing but what, guys? It's a constant velocity. If I mark it, constant velocity, guys. It is sinking with a constant velocity. Now, to explain this particular problem with the help of figure, for example, there is a lead which is having a in the form of spherical. This particular thing which are surrounded with the what liquid, guys. For example, this is the air. This sphere which is going to have some kind of what weight which is acting in the downward directions, and this is sinking in this liquid medium with the constant velocity. Remember, whenever it is there in the fluid, whenever any object, solid object, whenever any solid object is immersed in a fluid, there will be certain amount of buoyancy forces. And whenever it is moving in a fluid, the fluid will offer some kind of drag force. But in the problem, they have clearly given what they have given. We have to neglect the buoyancy forces. We have to neglect the buoyancy forces. So, my definition, if we try to balance the net force in the direction of our motion, which is equal to mass into acceleration, which can also be written as m into dv by dt. But they have clearly mentioned in the problem that this lead, which is having basically made up of lead, this particular solid spherical bead, which is made up of lead, it is moving with the constant velocity. So dv by dt will be zero. dv by dt will be zero. So what we can write, guys? Mg, which is acting in the downward directions, minus drag force, which is equal to zero. So what is the mg, guys? Mg must be equal to drag force. But the problem will not be finishing here. You have to find what is the drag force, guys. But you need not to worry, because drag force is already given in the form of what formula like this: half of CD into rho v square pi by 4 d square, where CD is given what, guys? 24 by RE. What is the Reynolds number, guys? Rho v d by mu. That is the formula we have. Now put that value 24 over. What is the density, guys? Density they have given. Let's keep the density like this. And what is the velocity? Let's keep it like this. What is the diameter? If you read the problem, the diameter, let me check. The diameter is given as 0.1 mm. What is the viscosity, guys? Viscosity is given as 1.1 into 10 power minus 3 Pascal second. Pascal second. If you try to put the values over here, D is what, guys? 0.1 into 10 power minus 3. We are converting in meter. 1.1 into 10 power minus 3. So what you can get, guys, from here, 24 over 1.1 over 0.1, you are going to get rho v over 11. So what you can get, guys, here, mass into G. What is the mass? What is the mass of the sphere, guys? We can write rho of solid sphere, G, volume of solid sphere, which is equal to half of CD value. CD value is what, guys? Rho v by 11, rho v square, pi by 4 d square. Now here you can see the rho will cancel out. V will be cancelling out here. So what you can get, guys, here? 24 into 11 over 2 over 4. What is the density of this particular object? 11,000, right? It is given as 11,000 into 10. What is the volume? Everybody know what is the volume, guys? Volume of the sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. But if you try to see here, what we can keep, guys? In terms of diameter, 3 by 2 whole cube. So what you can get, guys? 4 by 3 pi d cube over 8, which is equal to 24 into 11 over 2 over 4. You are going to get 33 into v into d square. Finally, there is a pi value also there. This pi and this pi will be cancelling out. This and this will also be cancelling out. You are going to get what, guys? 11,000 into 10 into 4 by 3 into d, which is equal to 33 into v. From here, what is the value of v, guys? Because diameter is given. The diameter is given as 0.1 mm. So if you try to substitute, you are going to get 11,000 into 10 into 4 over 3 into 0.1 divided by 1,000. So what you can get, guys, here? Half of the CD value we have kept 24 by RE. 24 by RE, where RE is what, guys? RE is given as rho v by 11. Rho v by 11. So here we have substituted the values. How much value you are getting, guys, here? If you see the, this step I will be doing here. I'm just removing this part. CD value we got 24. Rho v over 11. Rho v over 11. Rho and rho will be cancelling out after substituting this one. And V will be cancelling out here. So we are going to get 132 over 433. That is correct. The rho of body G 4 by 3. And here we have the pi. That pi will also be cancelling out. So 11,000 into 10 into 4 over 24 into 0.1 over 1,000. Yeah, so we are going to get the V value as 1 upon 80. You can see here 11,000. What we can do here? 11,000 into 10 into 4 over 3 T by 8, which is equal to 33 into V. D value, if you substitute 0.1 into 10 power minus 3, you can get the V value as 1 upon 18. 1 upon 18. That should be the unit, that should be the answer for this particular velocity in terms of what? Meter per second. Which options will be correct, guys? C must be correct. If suppose they have not mentioned neglect the buoyancy forces, then what is the buoyancy forces, guys? Rho, the volume of the liquid which is being displaced. Rho of fluid, G into volume of the liquid which is being displaced. The total volume is being replaced, so volume of the sphere will be coming once again. Right. But in the particular problem, if you can see that they have not given any kind of the density of the fluid. If it is not given, then also you can neglect it. Even you try to consider it by taking any air density in the air, whatever the buoyancy forces are there, that will be negligible, guys. That will be negligible because density of the fluid is what? Very, very less as compared to density of solid objects. So you can neglect it in that case. Otherwise, they have already mentioned in the problem. So we should not worry so much about the buoyancy forces. That is regarding the question number 3, guys. Moving on to the next question here. Try to read the particular problem. Consider a steady one-dimensional compressible flow of a gas in a pipe of diameter 1 meter. That means there is a constant diameter pipe. There is a constant diameter pipe. And they have considered two sections. I am considering section number 1. And here I am considering the section number 2. At one location in a pipe, the density and the velocities are like at a section 1, for example, it is 100 meter per second. And the density is given as 1 kilogram per meter cube. At downstream location, the velocity is what, guys? It's a 170 meter per second. If the pressure drop between these two locations, that is P1 minus P2, which is equal to what? 10 kilopascal. The force exerted by the gas on the pipe between these two locations will be what? Now here, what I'm assuming, first we are calculating the force exerted by the force exerted by pipe onto the fluid element. So for that, I'm drawing what? Control volume. This is my control volume, guys. In this control volume, I'm just finding how much of force exerted by the pipe onto the fluid element. So how to find it, guys? P1A1, that is the pressure force. Here also we have the pressure force. For example, P1, for example, P2. So what we can write here? P1A1 minus P2A2 plus Fx, that must be equal to mass flow rate V2 minus V1. Remember here force Fx is what, guys? We have assumed in the right directions. If we are getting the negative answer, that means what? We have to reverse our directions. And remember, we have written here Fx means the force exerted by pipe onto the fluid element. So if you try to see here P1 minus P2 into A plus Fx, that must be equal to mass flow rate V2 minus V1. What is the P1 minus P2, guys? 10 kilopascal. What is the area, guys? Area must be what, guys? Pi by 4 d square. But what should be the diameter here? 1 plus Fx. That must be equal to mass flow rate. What is the mass flow rate? Rho into A1 into V1, which is equal to what, guys? 1 into pi by 4 d square, which is 1 square, into V1. V1 is nothing but 100. So what we can write, guys? Pi by 4, 1 square into 100, 170 minus 100. If you try to calculate, this particular value, 70 minus 70 into 100 minus, if you try to do 10 into 1000, and if you try to multiply pi by 4, you are going to get fx value. You are going to get fx value as 750 pi minus 750 pi. Remember, this is the force we are getting. That means we need to reverse our directions. What should be the direction, guys? The direction of fx must be the direction of force exerted by the direction of force exerted by the direction of force exerted by the pipe onto the fluid element. It is there in the negative x direction. Now tell me, by the Newton's third law, what should be the force exerted by gas onto the pipe? It should be just reverse of that. That means what should be the force exerted by the gas on the pipe, guys? 750 pi. Same magnitude but opposite in direction. What should be the correct option? B should be correct. Always this type of problem, try to find it out. The force exerted by the pipe material onto the fluid element. Then try to reverse the directions. If they are asking the gas or the fluid element onto the pipe. That is the first trick I am giving to solve this particular problem. Second trick is that always remember P1 and P2 are what, guys? They are the gauge pressure. Remember P1 P2 are what, guys? They are the gauge pressure. Already they have mentioned the difference of pressure, so we are not having any problem. Though we have the constant diameter pipe, so we have not trouble in this way. But sometime in the problem, if they mention absolute pressure, we should take only what, gauge pressure. We need to subtract the atmospheric pressure, and then only we need to put into the formulas here. What is this particular formula, guys? It's a linear momentum equations. So three particular concepts we have been discussed through this one particular problem that you need to remember, guys. P1, P2 must be a gauge pressure, not absolute pressure. It should not be atmospheric pressure. They should be what, gauge pressure. Now moving on to the last problem, that is the fifth problem. You can see here what they mentioned, guys. Read the problem. Study two-dimensional flow field. You can see the stream function, which is a function of xy, where x and y are in meter, and the constant k is what, 1 meter, 1 per meter square per second. The magnitude of the acceleration at a point x comma y will be what? Whenever they have given the stream function, which is equal to k times of xq into y, with the help of stream function, guys, tell me how to find the velocity component. So you know that the what is the definition of the stream function? If you try to differentiate stream function partially with respect to any direction, if you try to differentiate the stream function with respect to any direction, it will give the velocity vector which is perpendicular to that directions. That means if I try to write u, you have to write minus dou psi by dou y, and whenever you are writing v, you have to write dou psi by dou x, where u and v are the velocity component of x and y directions. And remember, the stream function is only valid for 2D flow, not for the 3D flow. So coming back to here, velocity component, how to find the velocity component, guys? Minus dou by dou y of kx cube into y. So if you try to differentiate, what you can get, guys? Kx cube. What is the value here? Kx cube into y, right? Yeah. And then what is the next particular thing, guys? Here, u, which is equal to minus dou psi by dou y. V is equal to what? Dou psi by dou x. V is equal to dou psi by dou x. So here, what is a V component? Dou by dou x of kx cube into y, which if you try to differentiate, you are going to get 3kx square into y, where k is 1. So what you can write, guys? Minus x cube And this you can write 3x square into y. Once you got each and everything, what they are asking, guys, they are asking the acceleration. Acceleration is what, guys? For a 2D flow field, ax I cap plus ay j cap. Now, what is the ax? U into dou u by dou x plus v into dou u by dou y. So, what you can write, guys, here? What is the u? Already you got the u value like minus x cube. And what is the v value, guys? 3x square y. So, what we can get, guys, from here? U, what is the u value, guys, here? The u value, if we try to substitute minus x cube dou u by dou x, which is nothing but minus 3x square plus v, which is 3x square into y, dou u by dou y will be 0. So what is the acceleration at x equal to 1 and y equal to 1, guys? 3 into 1 into 1, which is equal to 3. Which is equal to 3, guys. Right. Now when you try to see what is the ay, if you try to find the ay value, what you can get, guys? U into dou v by dou y plus v into dou v by dou v by dou x plus v into dou v by dou y. So what we can substitute over here, guys? Ay you can get from here. U is what, guys? Minus x cube dou v by dou x. What is the dou v by dou x, guys? 6xy plus v. What is the v? 3x square into y. What is the dou v by dou y? It's a 3x square. What is the ay? At x equal to 1 and y equal to 1, guys? Minus 6, 1 cube, 1, 1 plus 9, 1 to the power 4, 1. So here if you try to substitute, you are going to get 3. Overall, if you try to calculate, what you can get, guys? Finally, what is the magnitude of the acceleration, guys? Ax square plus ay square. Now from here, if you try to calculate, what should be the answer, guys? Try to please check it out. Here, if you try to substitute the values, 3 square plus 3 square, it's a 3 root 2. It's a 3 root 2. So if you put the values, what you can get, guys? 4.243. That should be the unit of acceleration. You can see here that should be the unit of accelerations, the magnitude of the acceleration at a point x comma y. What they are asking, we have to round off to 2 decimal places, so that should be the answer. What, guys? 4.24 meter per second square. Please try to verify it. Here, steady flow means it is not a function of time. So if, though some of you might be thinking that dou u by dou 2 should be coming, but that will be 0. Here also that dou v by dou t, that term will be 0. Again, try to verify it. Ax, which is u is what given, guys? Minus x cube dou u by dou x. What is the dou u by dou x? It's a minus 3x square plus v. What is the v? 3x square y. What is the dou u by dou y? It's a 0. So finally, if you try to substitute, you are going to get 3. That is the x component of acceleration. Y component of acceleration, if you try to substitute u into dou u by dou x, plus v into dou v by dou y. So u is what, guys? Minus x cube dou v by dou x. What is the dou v by dou x? Dou v by dou x is what, guys? 6xy plus v is what, guys? 3x square into y. Again, what is the dou v by dou y? It's nothing but 3x square. So finally, if you try to substitute the values, again you are going to get 3, right? So this would be our answer, guys. 3 root 2, right? So that's all for today's session. If you have any doubt, let me know. Otherwise, we will close the session, right? Thank you.